Hello there, welcome back. So here we have an updated video on the 2D character following the mouse. However, as you can see right here, and here as well, this example allows the character to rotate on the game plane that is both rotated in any direction and has a portion of it in negative space. It does not rely on manipulating the character's transform directions, such as up, forward, and right, so it should be a lot more reliable for you. So if I just expand the scene view, you can see here that this game plane is at an angle, a crazy angle, but still it rotates nicely. And if I turn on my rotation of this just to show you, you can see that the character follows along the mouse nicely no matter which direction the game world is facing, the 2D game world that you've created here. So it could be underneath something, on the side, or on top. As always, the final code is in the description for you to grab, and let's jump into it. Okay, so as always, let's start with an empty scene. So you can see there's no hidden tricks going on in the background, and I've got some textures here just to help. Now we're going to start off by creating our 2D game floor, and we'll use that to detect where our mouse is in relation to the game world. So if I go ahead, I'm just going to create a 2D plane for this one. Let's make this big. And just to be fancy, I'll drop a sand texture on that. Nice. So this is going to help us in two ways. One way, it can act as your ground plane that has your grass or your dirt. And another way is it's going to help us with the raycast from the mouse down to this plane. So I'll call it 2D floor. And to isolate this floor from the rest of the game objects, so we have a better time detecting it with the mouse, we'll need to add it to its own layer. So let's make sure we have our 2D floor selected, and we'll go to our drop down here that says layer, and we'll click on add layer. And in one of the empty fields, you can type 2D floor, and we'll make use of that a bit later on. Okay, now we have our plane. I'm going to create the character. So let's go with a quad to attach our sprite to. I'm going to drag our trusty wobble texture onto that quad. And you can see it hasn't taken in the transparency, so I'm just going to change this to unlit transparent. That'll do for now. Okay, so now let's give this an empty parent to house our character scripts, and I'll call that character. And I'll call this one, I'll drag that under there, I'll call this image. Now I'm keeping these separate so we can manipulate the image object underneath without affecting the position and rotation of the motion game object above, which is this one. To show you why, in this example you can see that the quad is facing straight up, but I want it to be flush or parallel with the game floor. So I'm going to manipulate this image here by 90. And I want to make sure, just for me, I want to make sure that the forward of the character faces the Z axis. So then you can make use of transform.forward later on if you want to. We won't in this video, but if you want to. Now you can see here that our image game object here has values here, which we don't want to get in the way of these values here, which will be controlling the movement. We don't want them to conflict. Okay, now let's move that to be a child of our 2D floor. We do this so that whenever the game world moves or rotates, which is this one, moves, rotates, all of the characters and objects inside the game will also move and stay parallel with each other. So you can see here, if I go a bit closer, I need to move it down a bit, but when I rotate this, the character stays parallel, which is exactly what we want. Okay, so let me set the game floor back to 0 and the rotations. And of course, with your character, do make sure you raise it up slightly above the game floor, so we can see here if it goes too low, it will disappear. So you kind of want to act like it's got its own layer within the game world. So this layer here is for the floor, And then you could say, if I move this up by, let's say by 0.1, so the 0.1 layer is for my character. So there's no risk of it penetrating with the floor. Perfect. Okay, so I'm going to scale up. I'm going to scale up my character a little bit so we can see what's going on. I'm going to move that here. Cool. So all that remains in our scene setup now is, you don't have to do this bit, but I'm going to skew the game floor and the character to show that it will work at any angle. So I'm going to put my main camera, let's move it up. So it's top down, but not top down. Oh, I'm going to just rotate it a little bit randomly. Shaky shake. And then I'll take my 2D floor and I'm going to do the same. Rotate it randomly. Just so you can see it will work no matter the angle. Keep note that this will work for perspective and orthographic cameras. So that was one of the problems in the previous video. And okay, so the scene is now ready. Let's create our character follow script. So I'm going to call this look at mouse. And I'm going to attach this to our top of our character, which is right there. Cool. Perfect. Okay, that 2D floor is being a little bit too reflective, so let me just go here and turn the smoothness down. Perfect. Okay, so let's open up the script. Okay, so we have some functions to make. We'll be running this inside the update, but we won't put all the code here, we'll use a function. So let's start off with our main function. We'll call it look at mouse. And we will create this here. Void look at mouse. Ooh. Okay, so what's the first thing we want to do? We want to get the mouse position and then cast a ray from that position through the main camera down to our 2D floor. And then where that hits is where our character will be looking at. So first we will get our mouse position. So vector 3, mouse position. And to get that with the new input system, we will say mouse.current.position.read value. Now, if you don't have the new input system enabled, I'll show you how to do that in another video. Okay, now we have our mouse position. Let's turn that into a ray. So ray mouse ray will be camera.main, because we're going to be casting this ray through the main camera. .screen point to ray, and then mouse position. Now sometimes you might have a problem with this function here, screen point to ray, and if you do, that might be caused by mouse position. When it comes through, the Z value is 0. So you can try mouse position.z equals 0.01f, and that will just offset it slightly in the Z, and then that might allow this ray to work properly for you. Now I don't think that's going to happen, but just in case it does, give that a try. I'm going to delete that. Okay, so when you do the ray cast, we're going to need 2 extra things here. We're going to need the depth, so how far will that ray cast from the camera forward. So let's create that variable first. We'll do float raycast depth, and we'll say 100. And then we'll create another variable, and this one will be a layer mask. This is so when we fire our ray, the ray will only detect hits of objects that are on the 2D floor layer that we set up earlier. So this is our floor layer mask. Now to populate that, when the script starts up, we'll say floor layer mask equals layer mask dot get mask, and you can give it the name of the layer. So we'll say 2D floor. But just to make this a bit more flexible, let's add another variable here. We'll say string floor layer name, and then that will equal this. and then we'll put this in here. So it's a lot easier for you to change the name of it, change the depth. It's all up here and accessible for you. Okay, so now we have our mouse ray and we have our information here. Let's cast that ray. So raycast all will return a list of raycast hits. So we'll do raycast hit list mouse hits, and that will equal physics dot raycast all, and then the arguments are mouse ray, the depth, so we'll say raycast depth, and the layer mask is optional, but we're going to use one here, floor layer mask. Okay, awesome. So we have our mouse hits. Now let's check if any of those mouse hits actually have any hit information. So if mouse hits dot length, it's an array, so dot length rather than dot count, equals 1. So usually here you could say mouse hit, if mouse hits dot length is greater than 0, so if it's hit anything. But because our 2D floor layer, we only want one game object on that layer at any one time. We don't want any other object to get in the way of this movement script. So therefore, I'm saying if mouse hit dot length is equal to 1, if there's just one hit. If there's more than one hit, then we have a problem. So this will help us be quite strict. So if it does detect a mouse hit, let's get the position of that. So we'll say vector3 hit position equals mouse hits. I want the first element dot point. Okay, great. So now we have the hit position. So when the ray has cast from the mouse down the camera to the 2D floor, the point at which that ray hits will be the hit position here. Now we can move on to looking at that location. Okay, so here's where things get a bit tricky. Now our hit position vector is in world space, and it's going to have values on its x, y, and z. Now all three of them, x, y, and z, could be numbers other than 0. However, our character exists in a 2D plane. He has no concept of up and down. All he knows is left and right. So we're going to have to find some way to convert this coordinate here into something he can understand. Now, one way to try and explain this is imagine you're outside and you're looking forward. If you want to look at the grass, you look down. If you want to look at a car, you look forward. And if you want to look at a plane, you look up. Now, if we were to convert your world from 3D to 2D, if we were to flatten everything, now, if you want to look at the plane, you look forward. If you want to look at the car, you look forward. And if you want to look at the grass, you look forward. Okay, so we need to find a way to convert this hit position from 3D to 2D for the character. So what we're going to do is we're going to convert our hit position from world space to local space of the character. Then we're going to set the Y component of this hit position to 0, which is essentially our flattening. And then we're going to convert this position back to world space, and then we'll ask our character to look at it. Now, even though we're converting it back to world space, this world space value will now take into account the way in which the character understands where to look. The character can't look up and down. It can only look forward, back, left, and right. So by converting our world space position to his local space, we can then, in his local space, flatten the coordinate on the Y and then convert it back to world space. And wherever the mouse moves, wherever the raycast hits, we know that that position will always be flattened so the character can understand it. So to the character, he will always be looking at a position that, from his perspective, is always on his plane of existence, in his 2D world. Now, fortunately, there's a couple of functions we can use to do this conversion from world space to local space and back. So let's go ahead and use these. Right, so vector3 local hit position equals transform dot inverse transform point. And we'll give that our hit position. So what this is saying is take this world space position and convert it to the local space of this transform. Now we'll take our local hit position .y and we'll set that to 0. So we're flattening this position coordinate into something our character can understand. We will then convert that back into world space. So we'll have our final look position will be transform point, capital T, local hit position. So this is now going to take our flattened position and convert it back to world space relative to the transform. Cool, and now all we have to do lastly is go transform.lookAt, and we'll say look at the look position using transform.up to do the rotation on. Save that. Let's go back to Unity. Oh, we got an error. Okay, so the name mouse does not exist. Okay, so let me just double check that I have the new input system running. So I'll go project settings, go player, scroll down, new input system. Cool, so I do have that running. Where else could the error be? Let's open the script back up. So I have forgotten to use the namespace. So using Unity engine.input system. Save that, go back to our game. No errors, okay. So let's go ahead and click play, and it doesn't work. Okay, why? I think this is because my 2D floor, the layer here is not set to 2D floor. So when it's doing the raycast, it's not finding anything to hit. So set this. No, I only want to affect this top one here. Now let's try this again. Perfect, yes. Look at that. Perfect, okay, that's using transform.lookAt. Now, just to cover quaternions as well, very briefly. So here I will say this is using lookAt. If you're not a fan of transform.lookAt, then we can say using Quaternion. So here we will need a direction rather than a position to look at. So let me just comment that out. And here we'll go vector3 look direction instead of look position will equals look position minus transform.position. So if you want to create a look vector from one position to another, you say the thing I want to look at minus the position I'm looking from. So there's our look position, and then we'll go transform.rotation equals Quaternion.look rotation, and we'll give it our direction, and then again transform.up, just so it knows which direction to swivel on, which axis. So let's save this. We'll click play, try and test it again. There we go, perfect. Now you can see in this view, this is the scene view, if I take the 2D floor and I turn it upside down, and then in the game I try and look, you can see it's working upside down. And then if I take this plane, I move it completely into the negative of one axis, and then I go back to the game, it still works. So it's really robust, this code. Now let's unpause it. Now in the demo at the beginning of this video, you saw that I had this rotating as well, just every frame. Now we're not going to add that to our code, but if you do have a 2D floor surface that is rotating and animating, you can rest assured that this code should still work for you. Now let's go back to our script. Now this is pretty much the final code before it's been formatted to look a bit nicer. So if you want to use this as it is, you can go ahead. But I'm really quickly going to run through just breaking it down into 2 more functions just to make it a bit more presentable for you. So under look at mouse function, let's create a new function called get mouse floor hits, and that will return, so pretty much here the raycasting section we're going to move out into its own function. So raycast hit array, we're going to have this function here return this, and I'm going to want to take this piece of functionality, put it in here, and I will want to move this. I'll keep this in here, and I'll say that equals get mouse floor hits, and then I can replace this bit here with a return keyword. Okay, so we've broken out some functionality from this big blob here. So now this function purely handles the raycasting. Now we have this chunk here which we're going to break out. So we'll create another function and we'll say void look at position. And it will take a position to look at as the argument. So this function will handle the looking at. So let's take this chunk here and we will put this in here. Perfect, so these two should be good. Let's finish up our look at mouse function. So this one gets the hits and this one looks, and this one is kind of a master function that controls the whole process. But all we need to do now is say if the mouse has hit one thing, get the position and go look at position, hit position. Okay, let's give that another test just to make sure it's working. Looks all good. Yep, he's still facing. Okay, let's go back to our script. We'll switch back to look at, just so we can confirm that the look at is still working as well. Just going to make sure that this code is bulletproof as much as it can be. So let's try this again. Transform.lookAt this time instead of Quaternions. Yes, perfect. Okay. So back to the script. Okay, so lastly, the most popular part of the video is the doc strings. We'll do them in 30 seconds. Don't worry. We're just going to do short strings. So we'll say get mouse floor hits. What does this do? Okay, using the main camera and current mouse position, raycast through a specific layer, looking for the 2D floor game object. There we go. Okay, next one, this one. Look at position function will turn this game object to face a specific position, flatten the 3D position to local 2D space to maintain parallel rotation with the game floor. Perfect. And then last one here, look at mouse, face the mouse position while it's over the 2D game floor. And there we have it. This is the finished code. Now just to be sure, let's save it and run it one more time. Please work. Yes, there we go. Rotate this upside down. Oh wait, so the camera can still see it. Still works. Rotate it, still works. Move the camera a little bit over here. Still works. And we'll rotate it over there. Still works. Perfect. Awesome. So unlike the previous video, this does not rely on transform.up. And I saw a couple of comments on that video saying that they were having problems. So this should address all the problems so far that I saw. And I'm just curious, if I duplicate the character and I move him to the side a bit, and I duplicate it again, move it over there, I click play. Beautiful. Now they're all interested in the mouse. Okay, so thank you for watching, and I hope this video has been helpful. Please like and subscribe if you liked the video and you'd like to see more. That would be greatly appreciated. If you leave a comment, I will try and get back to you. I will try and help you if I can, and I'll see you next time.